Hello, and welcome to the FIB Young Members Group Rising Stars Podcast series, where we interview the most successful and prospective young engineers and researchers in the world. My name is Nikola Tosic, and I'll be moderating today's talk with Dr. Rob Wolfs, our third rising star in this podcast series. Rob is an assistant professor at the Technical University in Eindhoven, where he obtained his PhD cum laude in 2019 on the topic of 3D printing of concrete structures under the supervision of Professor Theo Salet. Since then, Rob has published more than 30 research papers, almost all of them on the topic of 3D printing concrete, from the material to the structural level, and is one of the most cited researchers in the field. He has also worked on landmark 3D printing projects such as the project Milestone and the Nijmegen Bridge, both in the Netherlands. He is also the recipient of numerous awards, among them the Best PhD Thesis at TU Eindhoven in 2019. Rob is also very often interviewed for magazines and radio on the topic of 3D printing, as he's a great science communicator. Thank you for joining us, and I hope you will enjoy the podcast. Hello, Rob, and welcome to the podcast. Thank you so much for joining us. Yeah, this is the third installment, actually, of the Rising Stars podcast series, and yeah, I'm really excited to talk to you because I think you're really a world expert in a topic that nowadays seems to be kind of in everybody's vocabulary. Everybody seems to be talking about it, and that's 3D concrete printing, right?
Yes.
So I'm really looking forward to kind of weeding out the fact from the fiction, in this case with you, but then also talking about things, what it's like to work at such a high and productive level as a young researcher, right? So hopefully our audience will hear also advice and kind of testimonial and your experience.
Sounds great.
So thank you again for joining us. And actually we are, let's say, now at a distance, so we are talking online, but actually we did meet in person, and I'll come back to that later. But actually you're the first person from whom I heard about 3D concrete printing, and the audience can't see, but yeah, I have some photographic evidence that we met in 2017 when actually I was part of a team of FIB Young Members Group that announced you as the winner of the first FIB Young Members Group Best Paper Award at the FIB Symposium in Maastricht. So was this your first contact with the FIB, and did it continue after that? Or if it didn't, why not? What is your, let's say, interaction or experience with the FIB?
Yeah, I still remember this, of course. It was it was a really nice conference. It was, for me, the first international FIB conference, and I think also maybe the biggest conference I visited at that time still as a PhD student. I was involved in some of the StuFib meetings or workshops. This is like the Dutch members group of FIB, but it didn't continue too much after that. And I think part of the reason is that a lot of the international community of 3D printing was united in a RILEM technical committee, where most of the research activities, including our own, sort of were united. And we contributed to that a lot in the past years as well.
And if I might follow up, I mean, this involvement in the RILEM, did it also come because your supervisor was involved? Because I'm interested to know, typically these kind of things are, I don't want to say hereditary, but a PhD student follows his supervisor into committees, so on, or was it your own discovery?
Yeah, I think maybe it was sort of it went a bit in parallel, I guess, because we were starting to work on this topic, and at the same time we saw some different initiatives popping up across the globe, and then I think via being invited for some symposium, we realized that this technical committee was just starting up, and we wanted to tag along, and this really grew into a huge group of people working together.
Okay. Well, I mean, within the FIB, of course, there are also initiatives, but yeah, I'm aware that RILEM is also very active and has, let's say, work. Sometimes there is work in parallel, probably double effort, and this is something to be optimized probably in the future.
I guess now that the technology is maturing and we see more and more applications in practice, so we're moving more from focusing on the process, material development, and so on to really structural applications. I think there's also a more obvious role for activities within the FIB related to this technology. Yeah.
Now that you said technology is maturing, and this kind of leads me into a second question, and we are now in, let's say, 2023 already. my first contact, as I said, with 3D printing was from you at the FIB Symposium in 2017. But this for sure was not your first contact with it. So when did you hear about 3D concrete printing? How did this, attract your attention? Yeah.
Well, for me, it started some years before that, indeed. It was when I was still a master's student here in Eindhoven. I was looking for a topic for my master thesis, for my graduation project. So here you have a 2-year master program, and in the second year, usually for about 9 months, you focus on one specific topic. So I remember I had this big mind map of innovative topics that were interesting to me in the field of structural engineering and design. So this was things like smart materials and topology optimization and robotics and also 3D printing. So I had this mind map made. And of course, I could not do everything because it was way too many interesting topics and difficult to combine all of them. And I was discussing this mind map at that time with my supervisor, Professor Theo Salet. And in parallel, I think some industry was talking to him as well about starting to work on 3D printing. And this, I think, almost coincidentally sort of coincided, and we decided to start working on this topic as part of my graduation topic. And then after that, after about 9 months or 1 year of working on this more from a theoretical perspective, so exploring what was happening in the field and what were the main research questions, we scaled up and we continued to work on this in the PhD project, and we set up a huge 3D printer in our laboratory, and that was really the start of a sort of journey that is still ongoing today.
When you say PhD project, was it, let's say, within the scope of, again, some national project or collaboration already with companies? How was that organized?
This was it was a collaboration between industry and the university. It was part of a so-called Impulse program, where there was actually 2 PhD candidates, of which I was one. 50% funded internally and 50% funded by a group of companies who were interested in this technology.
Okay. And Professor Salet was working, let's say, on this topic from some time before, or also beginning with you?
No, we actually we really started together to work on this topic and explore it. So it was really nice to, and we're still doing that actually today to see where the technology is heading. Yeah.
Okay, that's very interesting, because then you are, let's say, even more kind of equals, right? Because you are both in the process. And can you give us then, so this was, let's say, starting the PhD, and I suppose also in the Netherlands that it is 3 or 4 years, but can you give us a kind of your trajectory now after your PhD defense?
Yeah, so indeed, the PhD project is about 4 years, and I think I started in 2015. So around 2019, I defended my PhD in September. But actually, before that, I went to Paris for half a year, to IFSTAR, which is now called a part of the Gustave Eiffel University in the group of Nicolas Roussel. Because up to that point, I was very much looking at this technology from a structural engineering background, so using finite element modeling, solid mechanics approach, which is what we are trained for here in this group. But there I took much more a rheological perspective, so looking more at the material from a fluid perspective and CFD modeling, which broadened my scope a bit compared to what I've been doing during my own PhD project. So when I came back from Paris, I defended my thesis, and I continued as an assistant professor at TUE. And what I have been doing since is what I like to call digital design and manufacturing technologies for applications in the built environment. So this means using new techniques to design and construct our buildings, our bridges in a more efficient way. So you can think about optimization strategies, parametric modeling, numerical analysis to design with less material. And on the manufacturing side, this is indeed robotics, but also still 3D printing, of course. And I've been setting up some research projects with PhD candidates, for instance, on these topics. But in this current role, I'm also, of course, teaching courses on topics related to the structural design of concrete, but also related to robotics and 3D printing.
Well, there are several follow-ups in different lines, but I want to pursue this one of, let's say, more the professional line of your trajectory afterwards. So you also said yourself that you did a bit of this shift by going to Paris and looking at different, I would say, part of the kind of, I don't know, value chain, let's say. But from your publications, then it's clear that you focus from the material formulation to the printing technology to the structural analysis. So do you consider any of these parts currently maybe more important to work on, or let's say more important in general? Do you find yourself liking more, dedicating more to one part than the other?
I think they are. I think it's actually essential to consider them, I would say, as equal and as connected, because they influence each other a lot. But what I, of course, did realize, I was trained as a structural engineer, as a designer, so I had to catch up a bit, I would say, in terms of material behavior and rheology and so on. And the same goes actually for operating and programming robots. I had no experience in that before I started to work on this topic. But the reason why I say they are equally important, I think, for technologies like 3D printing, but it goes for other robotic technologies, more advanced manufacturing methods as well, is that these three things, they influence each other a lot. And if you look at them as isolated topics, or if you look only at material behavior, or if you look only at structural design, and you do not consider the way you manufacture them or the way the material behaves in that manufacturing process, then the results don't make a lot of sense. So it's actually quite exciting to be in this field where you continuously have to collaborate with experts from different disciplines and bring that knowledge together.
I don't know how you think about it, but I think so. Your background is structural engineering. I think that would say can bring an advantage in the sense of that, at least when you're formulating the idea, you know what is the objective, to have a structural material because it has to fulfill certain criteria, resistance, so on. I would presume that maybe if your background is more material, you're developing a material, but for what? Then you don't know what are later the structural requirements, but this is somehow you are starting kind of from the top down, I would say. You know what you want as the end result, as a structure, what it has to fulfill to be designed, safe, reliable, and then you go down to the right technology. I don't know if you agree with this.
Yeah, exactly. And it helps because it steers requirements in terms of material performance, but the other way around, the material behavior and the manufacturing process do in turn also influence the properties of your final product. So if you don't understand these things, then you might actually end up with structures which are unsafe or behave differently from what you expected.
And how much would you say that, I would presume a lot, but that the technology and technology readiness of the industry and also research changed over the years since you started, so 2015 to now? Yeah. I presume that probably you could maybe not have even imagined all the technology that would be available today to be printed.
Yeah. No, it will really, you often see these exponential graphs, right? And nothing is happening, and then suddenly it just explodes. And I think this is what happened to 3D printing in construction in the past couple of years. When I started this master's thesis that I mentioned before, I remember there was a press release coming from China. There was some first company that announced that they had printed some very first houses. So this was really the very first news item like this. There were some examples, but not on this scale of really a house. And this got a lot of attention and all over the news. And if you look today, so some years later, I think every week, maybe even every other day, you could find another press release of a new house or a new bridge being printed all across the globe. So it has really exploded in that sense.
But do you see more? Because let's say this is kind of cutting edge technology, that is it being uptaken more by the kind of traditional construction companies that now decide to go into 3D printing, or are they kind of disrupted by companies that are more maybe technological and see here an opportunity to go into construction?
Yeah, that's a very good question, and I have the feeling for now it's both. I see startup companies that maybe already in a bit earlier phase started to explore this technology to try to disrupt the construction sector. At the same time, I see more and more of the established big contractors and national, international players who are buying printers, who are setting up robotic factories to assemble houses in a completely automated manner. So I see a shift in the past years. It's not like all the houses I'm looking outside of the window are being 3D printed suddenly, but there's a big shift in what happened when I started about 8, 9 years ago, and what's happening in the past couple of years.
So, for example, in the Netherlands, is it still at this stage that there are startups appearing, disappearing, or has it kind of consolidated now that you would say it's more stable, and then the companies that exist, they will now keep developing?
I still see startups appearing, but yeah, I guess, and I think that's a good thing, because that leads to new development, leads to competition, and that generally, I would say, leads to improvement. At the same time, I think the Netherlands is only a small country, so at some point maybe it doesn't make sense to keep coming up with new initiatives, but actually team up amongst them. And I guess that's also where universities can play a role in collaborating in such consortia.
Because I also ask because I think you have probably a kind of unique perspective on the, let's say, construction industry, because my thinking was, people who are in more, let's say, traditional concrete research and practice would tend to maybe, I don't know, complain or characterize the construction industry as inert, slow to adopt innovations and so on. But your entire career has been in this cutting edge, very dynamic sector. So you probably perceive the construction industry very differently. And I wanted to ask you, what is it like from your perspective, and what's its perspective for the future? So for the construction industry, because some would be a kind of, doomsday sayers that, it's polluting, it's slow to adapt and so on, but you're at this very dynamic end. So how does it look there?
Well, I cannot disagree, of course, with what you said, because if you look at the numbers, it is exactly true. The impact of the construction sector to environmental issues is huge. And if you look at the productivity, so how efficient the sector is, it's very low compared to other sectors like manufacturing, for instance. And in many countries, including the Netherlands, we have a huge deficit of houses. So actually, we have to build a lot, but the way we are doing it is not very efficient and not very sustainable. So there is a big challenge. And well, I can imagine that if you mention the construction sector to somebody, then these things pop up. But you could also see it as an opportunity. So there is a lot of potential to have a positive impact if you can improve, if you can make this sector more efficient, more innovative by introducing these new and digital technologies. And I think that's the angle that I like to pursue, that I see it as a challenge, but at the same time also as a very interesting opportunity to really make a change.
Can you give us maybe just a brief overview of what can be openly said about what are some projects and research lines that you are currently working on?
Yeah. So one of the topics that we are pursuing is to be more in control of the manufacturing process in varying conditions. So that means that whenever you want to print some object, you want to do it what we call first time right. So you want to know exactly what you have to do to reach the desired output with the right quality at the maximum speed and so on. And this can be inside, but it could also theoretically be printing outside in all kinds of wind and weather conditions and so on. And to do so, we have been extending our, let's say, traditional tools that we have as engineers in terms of numerical models, in terms of experiments that we do. We also started to explore the opportunity of collecting data with a lot of sensors and trying to learn from this information that we collect in a non-destructive way during printing and during the use phase. So this is one of the topics that we are exploring. And if we can collect this information, if we can learn from it, then we can start to predict what will happen. And if we can predict it, then we can also start to optimize it. So we can change, preferably in real time, the quality of the process to reach a certain level.
And this you are, let's say, performing again within a research project with PhD students?
Yes, exactly. So this is with PhD students, and at our university and other universities in the Netherlands as well, we also have so-called engineering doctorates, and these are more design oriented. So they are 2-year projects, often with industry involvement. And we've also done some of these projects where we look more at design applications. So assume that we now understand this printing technology and we can be in control, then we still actually don't know what to make with this technology? Are we going to make the same buildings and bridges that we can make with conventional technologies? That doesn't make too much sense. So we are exploring there and also making and validating designs for 3D printing. And that's also it's a different scale, but it's a very interesting research and design field as well.
Have you been contacted by Elon Musk for 3D printing on Mars?
Not personally, no, but it's of course an interesting idea, and I actually do see some startups funded by NASA or by ESA printing with moon dust. On
Yeah,
some
there was an FIB webinar actually with Peter Collins, I think, yeah, his name, from University of Philadelphia. That was a kind of NASA fellow, and well, they were sending stuff to the International Space Station, but the kind of future idea was to be doing 3D printing, the only way actually to be constructing on the moon in this case, and then probably on Mars. So yeah, it's a technology that's out of this world, let's say. We can
absolutely
really say, but sorry.
A bit closer to home, I also see, so not on Mars, but I also see some military institutes investing in technology as well, because like on Mars, going to remote areas that are difficult to reach, it would of course be very nice if you could have an automated technology that can build whatever it has to build for you before you can send people there.
Yeah, this is definitely for sure. And coming back more now, close down to Earth, let's say. Can you introduce our listeners? I wanted to ask you about, let's say, two projects that are also, let's say, widely visible, and one is the project Milestone. So can you introduce our listeners to that project and why it is really a milestone, maybe with some technical details, the technology used, construction time, some monitoring, and so on?
Sure. So Project Milestone is a series of 3D printed residential houses. So they are houses just outside of Eindhoven, 5 of them, and the idea is that we print all of them and we increase in complexity over the course of the project. And the first house is a single-story residential house of about, I think, 95 square meters. And it was opened and it's currently inhabited in the summer of 2021. So it has been there for about 1.5 years now. And the idea was that the printing technology would really provide the structural load-bearing elements. So all the forces are to be taken by the actual printed concrete. So that means it had to comply with regular safety and quality standards, of course. And that meant, as a university, there was a clear role for us to do testing and validation and show that that proof of concept worked. So the project is a collaboration between the university, the municipality, and a number of industry players.
And do you know, is it really inhabited? I mean, it's a primary residence of the people who bought it.
Yes, absolutely, yeah. And exactly that made it an interesting challenge, because it wasn't just a demo or a pavilion or an open air museum, but it should be an actual house. And yes, it is printed, but it should not feel any different from when you buy, let's say, a regular house.
Was it easy to find the buyers for this house?
Well, actually, it was sort of an open call for people who were interested to live in such a house, and they got to choose somebody to live in it, because there was sufficient attention.
Okay. And it's I presume then you can even have kind of continuous feedback from them on their experience, right?
Exactly. Yeah. And apart from let's say the more social, personal feedback, of course, these structures are also being inspected and monitored to see how they perform in terms of durability, in terms of structural performance, more long-term behavior. Yeah.
And was this a kind of wider, let's say, project? There was some architectural design of how the house will, let's say, look like, then choosing the technology.
Yes. And this is where the word milestone is also a little bit of a joke, because if you look at the renders of this project, it looks a bit like stones, like big boulders, big rocks are sort of dropped organically into the landscape. So it was a milestone in the sense that it for us was the first printed housing project that we realized in practice. So that is for milestone for sure. But also actually the houses, they look like stones in the landscape.
Okay. I see this is a theme then in your work, because I see one of the papers has a title with the good, the bad, the ugly. Then there is a play on words with milestone. Okay, that's Very, very nice for, like, what they call them, Easter eggs or hidden
Exactly.
messages. Okay, okay. Probably maybe you have printed them some message in the house to to also discover. Okay. Um, so, and this was now, let's say, envisioned to continue in some way, or yeah.
Yeah. So we as a university, we mainly played the role of showing that the concept works and that we can manufacture these elements, that they are indeed safe. So we did a lot of structural one-to-one skill testing on these elements of the house. And then the industry group, they produced the actual and assembled the final house, and they made the final structural calculations that were the basis of the building permit. And that's also the way to proceed now in these next houses. So the idea is to make 5 in total. And again, the university will play the role of further developing and pushing, let's say, more from the innovation side, the technology, and showcasing it that it works, and demonstrating it by means of testing. And then the industry produces the elements, assembles them, and so on. So it's a really collaboration. Yeah.
And in this, you said that, of course, the municipality is involved because somewhere it has to be built. Did you encounter any barriers or like resistance to this project, or skepticism, or what is the, let's say, what was the most difficult in that sense to overcome? Or was it like, hands-free, do whatever you want, this is great?
Well, the nice thing is that they were very open and involved from the start of the project. So they really they were really not in a very skeptical way looking at this technology. But at the same time, they of course have to sign off on the project. So somehow we had to guarantee that it was safe, and there is no Eurocode or FIB model code for 3D printed concrete yet. So one of the routes that we took, and this was of course a bit time and labor intensive, is that we had to make some parts of this house on a one-to-one scale, and load them really up to the design loads to prove that the whole principle and that the printed concrete is safe and sound compared to conventional methods. And yeah, in that sense, it is a barrier because it means that you sort of have to make everything twice, first to show that it works, and then again to make the final object. And this for sure is something that at some point will have to change. Otherwise, the technology is not competitive at all.
But you have not encountered, let's say, barriers or negative reactions in terms of aesthetics from anyone that
Yeah, well, of course, there's different opinions on, and if you look at some social media posts, and if you look at some reactions, and you can see the most positive ones that really praise the innovative nature of such projects, to those that really find it ugly. And well, that's a matter of taste, and I guess that's the way it is.
Yeah, of getting used to.
Okay.
So this is, let's say, one part of one type of structure, let's say, now going into the residential, but I think you also did work on, we would call it maybe infrastructure. So there is,
Yep.
I understand, the Nijmegen 3D printed bridge. So can you tell us a bit about that? Because now this is really going into the structural part, right? And we had here, well, if anybody from the FIB Presidium was listening, so they should know there is not a model code for 3D printing. So, and there should be one. So how about the bridge? How did that go actually?
So in terms of process, it was a bit similar, but in terms of product object, it's of course very, very different. It's a bridge, but here as well, the idea was that the printed concrete would be the load-bearing structure, but we made use of a pre-stressing system. So we printed multiple elements and pre-stressed them, and by assembling multiple of these pre-stressed sections together, we created a bridge of about 30 meters in span, but not in one continuous span. Actually, it is supported by multiple columns along the way. And it's a bicycle bridge, so in terms of loading, it's still relatively minor, which I think for such first projects makes sense, that we do not immediately go to the most extreme cases. But in terms of the project and the process behind this, it was actually quite similar to that housing project, where there was a sort of municipality, a university, and a set of industry players collaborating from the start of the project, and moving from a design vision, so how the bridge should look, to printing some parts of the bridge to demonstrate that it works, and testing them again on a one-to-one scale. And after all of that was successful, then actually the industry players took over and started to produce the bridge, and assemble it on the building site or the final location.
I have to ask, were you convinced from even before the project started that it was feasible?
Well, yes, because it was a follow-up on a smaller bridge that we did earlier. It's more simple in terms of size, in terms of geometry, but it was also based on this pre-stressing system. And of course, we had been testing our materials already for a while, and we knew that even though it's printed, if you print it in the right way, it's actually quite similar to conventional concrete. But the tricky thing, of course, is that the complexity in geometry is much higher. It's much more slender structure, much more free form, and so on. So, of course, we played a bit on the safe side in terms of material use, you could say.
Okay. And let's say now you were saying each of these projects has a industrial partner, so it's a very direct collaboration with industry.
Mm-hmm.
And I think this field also is, let's say, very connected. So it's difficult to do research on this topic if you're not collaborating with industry simply for the technology and so on. But at the same time, my feeling is, and you'll correct me if I'm wrong, that a lot of these companies want this as proprietary data, right? So it's kind of confidential, or at least parts of it are confidential, both the results, technology. And how do you work with that as a researcher? Then at the same time, you always push to make everything, open access available, but at the same time, it has to be, let's say, maintained confidential for further exploitation. So how do you square this circle, let's say?
Yeah, that's it. That's a very, very good point, and it's a bit difficult. From the one hand, I understand, of course, from a competitive perspective, that some things have to be confidential. At the same time, I think I would say we're all in the same boat here. It's a relatively young technology where there's still a lot to be developed, a lot to be studied and improved. And I think we can go much quicker if we team up. So the companies, the industry players that actually open up and team up, for instance, also in these international technical committees, I think on the long term, these will progress much quicker than those who work more in an isolated fashion on their own. At the same time, in academia at universities, we are of course also dependent on funding either coming directly from industry or by companies teaming up in international research grants, for instance. And we are of course very happy that these companies are willing to do that. And if that means that there have to be some parts of the project more confidential, more dedicated to one partner only, well, then it's also a way to keep moving forward as a research group. But in my personal preference, of course, is to be very open in terms of everything that we develop, because I think that's the best way to move forward.
Okay. No, I mean, because it's a very specific area in that sense. I think because of the technology aspect, because when it's traditional construction, of course, everybody's doing it in more or less the same way. And here it's very, let's say, company or technology specific.
And I think on top of that, I think many of the questions that we are trying to address are generic enough to be open and shared amongst companies and universities and so on. And then each of the companies can still develop their own material or their own printing technology within such a framework. And if we do it like this, then I think, well, the companies can still be competitive while the research is not limited to collaborating only with one company, for instance.
Yeah, no, I agree. No, I'm also asking because, of course, is it in conflict? We are, as researchers, as I say, measured by some metrics and, papers nowadays for, publicly funded projects. Everything has to be open access. Of course, this is another, way when it's justified for exploitation, that it's kept confidential until there is a patent, until there is something that is protected. Then, of course, it's legally covered in that way. But I also wanted to ask you then in this sense that, as we said, let's say you are from 2015 in this field and very dedicated to this field. All your career, right? I think also your publications speak to that they are, say, the vast majority on 3D concrete printing, but all of this value chain, right? Mm-hmm. But I wanted to ask you, I mean, this is maybe not so common nowadays in the sense that researchers are really dedicated to one field, which I think is the better way. But of course, we see everybody needing to kind of branch out into many topics. Then they are entering topics they are not experts in. and sometimes doing things your way is not maybe rewarded adequately by measuring these research metrics, right? How should I say? So yeah, I mean, do you see your way of working kind of in conflict with these today's incentives and promotions in academia, or has it been, let's say, easy in this sense to keep focused on one area?
Yeah. That's really a difficult one. I think it's not necessarily in conflict, but I do recognize your point, of course. Um, what I see happening around me at university level and at actually at national level at universities, that there is much more discussion on not only looking at metrics, so quantitative indicators, but also look more at qualitative indicators in terms of collaborations with industry, in terms of impact realized through collaborations and so on. So from that perspective, this is also something that I've been pursuing, of course, in the past years, that it's not only about the publications and citations, which is, of course, very much appreciated if you see that one of your papers is cited nicely. But I try to pursue these other ways of impact as well, and being able to realize these houses or bridges together with industry, or being able to work internationally with some researchers that I look up to. For me, that is also a very valuable way of doing my job, and I see that is also more and more recognized. That being said, yes, there is indeed a clear focus, of course, on these numbers, on these metrics. Um, and that's a balance that we are in, I would say, in our field. Um, Unfortunately, or yeah,
I
maybe.
mean, not just, of course, I mean, you don't have a problem with metrics either. I was just maybe referring to the way that, of course, you dedicated yourself very much to this one field. You believed in it, very passionate
Yeah,
about it. It could not have worked out, perhaps, right? And
yeah,
then, right, you need this branching out, etc.,
yeah,
etc. So this is maybe an additional risk that is not rewarding in academia. This really
yeah,
dedicating to something, not being 100% sure it will work or how it will work, or
yeah,
yeah, I think maybe expecting from researchers, one paper a year enough, but make it really, really good, better than, X papers per year and
yeah.
so on. And in line with that, I mean, was it difficult or let's say stressful period to get the position at the university after your PhD? How was this process?
Well, it sort of went in parallel to finalizing my thesis, because the position was open already just before I finished my thesis. So I was doing this a bit in parallel. Yeah, it's I guess anybody who is had experience in applying for a job in academia knows how the process is, and this was no different. But maybe the benefit at that time, I was one of the few, I guess, that was close to finishing a PhD on this specific topic, and I guess that helped in being able to continue now in this current position. Yeah.
And how do you see the perspective of let's say the current PhD students? Are they more encouraged to go into industry? Of course, now there is
Yeah.
an industry to go to, right? Probably
Yeah.
when you were
Yeah.
finishing a PhD, it was in an earlier state. So
Yeah.
where would I go?
Yeah. Exactly.
Or are they encouraged more or interested more? Do you see them interested more in pursuing some position somewhere in academia, or already jumping into industry there?
What I feel and hear around me, it's a bit of both. So, like I said, these more traditional companies, they are transforming, so they are adopting these technologies. So suddenly, their positions in terms of digital fabrication or digital engineering, that could be interesting for them. Uh, some are also more interested in the startup scene, so they actually start their own company on a specific topic. But also in academia, I see more and more research groups or even chairs or professorships on digital fabrication or structural design for digital technologies appearing. So I guess also there you see new openings, new groups appearing, where they are looking for people with a PhD on topics like this. So I guess there are more and more opportunities there as well.
And in terms of, let's say, undergraduate students and studies, has this, let's say, now trickled down into a curriculum? Is it being taught in any way?
Yeah, we have included that. Not yet, not as this is an elective course, so the students who are really interested in these topics, they can follow a course where we where we look at 3D printing as a technology, but also at different digital technologies like robotics and parametric modeling and so on. And they get to sort of extend their skill set with these techniques. And I think the students who recognize that they find this interesting and that they might find it useful for their future career, those are usually the students in the lecture room. And I must say that that's also always a very nice group of students to work with. Yeah.
Okay. So yeah, it's let's say selected group. There is already a filter, so they come already interested. They are not there, and then you have to make them interested. That's
and I think that's fine. It doesn't have to be that suddenly everybody should know everything about 3D printing or robotics. It's not like this will be the only technology in the future. But for those of the students who have interested in this, then yes, there is the opportunity to dive a bit deeper into the topic.
the topic. And this, let's say, a way also of filtering up for future PhD students? Do they end up being interested in a PhD?
Yeah, potentially. Although you also see, of course, internationally that there's a lot of interest to work on these topics. But this is also a way to look within the department to see which students would like to continue working on this topic. Yeah.
And now that you said internationally, and let's say more and more groups popping up dealing with this topic, is it more kind of landscape of these groups collaborating very much, or they're kind of insulated, isolated, everybody pursuing their own line?
Fortunately, I would say it's the first one. And what helps is that really from the start in these international committees, people have been teaming up and really sharing results, writing papers together, and currently are even doing inter-laboratory studies. So we are doing tests at different labs and comparing and sharing all the results.
Okay.
And I think that's really one of the nice things about this topic is that the topic itself is already quite interesting, but being able to work on it with a lot of international peers and experts, that's very rewarding. So I'm actually very happy that it's like this. Yeah.
Do you ever see yourself getting tired or exhausted of the topic? I mean, if at one point, in 15 years, it's common practice in industry, it's already at the level, it's completely uptaken. Do you see yourself moving on to other fields? Like this is now regular stuff. This is now my job here is done, or you are so passionate about it that you will continue nonetheless?
Yeah, it's difficult to predict, but I think at some point, because what I really liked about this technology and still do is that it's relatively new. So there's a lot of things to figure out, a lot of problems to solve. And maybe at some point, if these main challenges have been addressed, then I will probably move to some direction where there's new things to figure out and new problems to solve. But it could be that this keeps on developing and keeps on evolving, and my interest will always be there, of course. And I guess that goes for anybody with a PhD in a certain topic. It will never fully leave your mind or your heart. But
no, like of course, shear is still a
yeah,
topic. So of course, 3D printing is going to be then a topic for
yeah,
very, very long time if this is still. No, it was just this perspective. Is it what is new, or is it specifically this that is what is let's say catching your attention? And have you, what is your contact with the use of, let's say, recycled waste materials? This I'm asking kind of from my side,
yep.
where it was recycled aggregates, fly ash, slags, alternative binders, aggregates. I see this also kind of now entering and trickling down into 3D printing. Have you had an interaction with it? What is your opinion?
Yeah, it's extremely relevant because what you see right now is that we sort of, and I mean we as the whole community have been advertising the technology to be potentially more environmental friendly, right? Because you can use less material, you place it only where you need it in an additive way. But at the same time, if you really look at the material compositions that are being used mostly, you see a relatively high cement content and a very low level of large aggregates. So effectively, maybe we are not being that sustainable at all because of the high impact of the bulk material. So we have to address this. So we have to reduce our binder content or replace it with alternative binders, and we have to increase our content of aggregates, not just from an sustainability perspective, but also from a durability perspective. And I think including their recycled aggregates, so reusing materials, reusing components, is a very relevant and almost obvious topic that we should include in that development. Yes, for sure.
Yeah, this is of course, I mean, the large aggregate content, even okay as itself, would be good for the uptake, but let's say coarse aggregates, they have their own kind of entry point into construction. But I think for recycled materials, the interesting thing is precisely this fine aggregate, because the recycled one in traditional construction has very little use, because of the high water absorption is typically forbidden by codes, or at very low percentage. This is maybe the entry point for that fine aggregate into construction, for finding it some structure, any structural application. But I mean, also, of course, technology itself is very kind of disruptive, so it's changing the design. Now this has to be parametric design, topology optimization, so it's a completely different tool set or a skill set that an engineer needs. How do you see this disrupting, I mean, the now design companies? So we talked about maybe some startups entering into the technology space, but are there these startups, or how have the designers adapted to entering into this field?
Yeah, I have the feeling that maybe the designers, the engineering firms, they might have been a bit ahead in that sense, that parametric modeling tools and programming and all kinds of advanced numerical analysis have been around a bit longer, but maybe it hasn't really picked up because they were only used for very specific niche projects, like a huge soccer stadium or a beautiful hospital or museum. And that makes sense, I guess, because there you can have the budget to with traditional construction methods make such complex structures. But now that we increasingly see robots and printers to also make, let's say, the more conventional structures like residential buildings and smaller bridges and so on, then it suddenly also makes sense to start to invest in these digital design techniques for those projects. And then also the designers, the engineers will start to make use of them more and more. And up until now, it might only have been in those unique projects where it really pays off to start to invest in some optimization tools and so on.
And what is the, let's say, we said that there is no model code, there is no Eurocode. What is the situation with the standardization? Because there is the whole process that has to be from the materials. So concrete, maybe it's not EN 206 that's for the concrete, the standard for execution, the standard for design. So it's a huge work. It's for all the standards that you need, reinforcement and so on. What is the situation there?
So one of the activities in this technical committee that I mentioned is that we are working on an interlaboratory study on the mechanical properties of printed concrete. So a huge set of labs and also some industry involvement there, by the way, is performing a set of experiments. And what we are aiming to do is sort of collect all of this data and try to extract some, well, maybe call it a pre-standard or at least some sort of recommendation in terms of what you should test and how you should test this in terms of printable concrete. And this could be a first step towards some sort of standard in the field. I think that is one direction. The other, of course, is that it is still concrete, right? So we print it, but it's still a material that we know for a long time and that we have all kinds of safety standards for. So at the same time, I think we should also look where we can stick as close as possible already to existing codes and maybe add or prove in some cases where we deviate that this technology is equally safe.
Okay. So it's let's say more of an incremental approach than going from scratch and everything new. Yeah, I mean, some time ago, of course, pre-stressed concrete was not reinforced concrete, and then it was realized that it is just a different, in this case, different casting technology.
Right.
Yeah. Well, and okay, I am not the expert, let's say, to go into really detail, and the podcast is not the place to, I mean, ask you now, okay, in this mixed design, what was the content, this and so on. It was more to touch on kind of general overview and hear from you this general perspective, because these are conversations everybody has, does it have a future? Well, it's not going to be for all applications, so on. I think this, I think that, but I think that hearing from you, it's more valuable to kind of put us in the right place. But of course, then this is, of course, consuming your, let's say, entire career, and in research, our career consumes a lot of the time.
Yeah.
I mean, and everybody's talking about mental health in research, burnout, and so on. What are your, I mean, just some general tips of kind of surviving and thriving, as they say, yeah, even being so passionate about this is a danger. It consumes you, right? So
Yeah.
what is your, let's say, approach to this, or advice to others who are in the position? Because now there are more and more PhD students on 3D printing. So knowing now what you didn't know then, how would you advise them to approach their topic, to approach their work and career?
Yeah, well, I try not to give too much career advice, I guess, to students, because I see I'm still very much in an early phase. At least that's how I consider it myself.
Well, career, I mean, but the most valuable experience is from a relatively recent PhD. So a young
yeah.
assistant professor. This is, I think, very good advice in terms of, how to think about organizing their life, what importance to give to this. And
yeah, so this work-life balance, like you mentioned, is of course very important. And I must say, I've also already been on the wrong side of that balance before. So I also learned from it from that perspective. I I'm very passionate about this topic, of course, and I also invest in it in terms of time, and that means especially when you're working on some publications or some research grants, then it's really not a problem to spend some more time on it than maybe what you should. At the same time, I think it's important that on the long run, this balance is right, and that if you can keep and gain sufficient energy from your personal life as well, that will also pay off in your work. And well, everybody will have their own balance in that sense. But it's not all about 3D printing life, even though it's a lot of fun to work. But yeah,
even if it were, I would say, I mean, for me, thinking about this over the years, and what I realized as important in the group that I am, for example, now, and then I try to transmit it to my PhD students, is I also would say I'm very passionate about the work, dedicate a lot of time to it, but you don't have to, if it's a personal decision, right? So
exactly.
and you said you can be on the wrong side of things, and then you will hit your head against the wall, but that's you to deal with it, but not expecting that maybe from your team, from members, right? So even if I'm choosing and you're staying late or dedicating, it's not that it's required from everyone. It's kind of my personal choice, and this is not required to be emulated in a kind of way. This is, I think, a good way to set it. And then, of course, if somebody wants, I mean, yeah, but always also try to keep this balance. And this is not, because you will have teams, of course, where if the leader of the team is, has to be the first one to leave, the others have to stay longer or whatever. Not to copy that or make people copy that. Yeah,
I fully agree. Yeah.
So yeah, hopefully it can be a healthier generation of these young researchers coming out. But yeah, of course, we are all uncertain also about the times ahead and everything. So I think also research is a nice place to be. I mean, we are doing interesting things and have a very dynamic position, interaction with a lot of stakeholders and actors. Well, I mean, Rob, thank you so much, really, I mean, for your time and for really all the answers. I'm sure that, well, people will know that you have given interviews in Netherlands and other places, and perhaps I hope it was not too repetitive from you, that you are, let's say, always repeating, having to give the answers to the same questions. I try to mix it up a little bit, and I really hope the listeners will appreciate. And I think we will do this again for sure, if you agree, because if the technology evolved so much between 2015 and 2023, by 2029, 2030, it will be something completely different again. So we will talk in the meantime, I'm sure, many, many times.
Perfect.
Thank you so much for dedicating your time to us. And I hope to talk to you again soon.
My pleasure. Thank you.